Hey, welcome to a new lesson in Algebra 2. We're going to talk through this and take a look at this. In the past, I've given this one to students and just let them play with it and then wandered around and helped build meaning. Today, I'm going to do a little bit of demo with it. It's always been a little bit open-ended, and I want to see, I'm going to want some feedback from you at the end of this lesson to see how that goes. So I'm going to hide all of this for a second and just let you take a look at what I have here. So I have this function. It's a function because it passes what test? That's right, the vertical line test. So no matter where I run a straight line through there, it only hits the, I guess I'd call that orangish red line once. So we're calling that g of x. So g of x is what you're looking at right now. And then there's all this fun, scary stuff next to it. There's f, which oftentimes stands for function. There's x still, but now we're going to subtract h and we're going to add k. And the reason we're doing this is so that we can start to create some ideas, look for some patterns that would make it so that in the future we could write really awesome equations like this. So here's what's going on. Right now it appears to you like we have one equation. I don't want to freak you out, but if you look over here, there is all kinds of good stuff written. And we've purposely chosen a graph that isn't like anything you've ever studied before or that you would know how to do the equation for. And spoiler alert, there is really two graphs. One of them is the original, and then the other is we're going to do things to it. So what I'm going to do is I'm going to use a slider, and this slider is going to make the number that I'm adding, the k, bigger. So right now I'm not adding anything. But watch what happens if I add 1. So keep in mind the red was the original, and then I added 1. Did you see what happened? How would you describe, I'll put it back at 0 and do it one more time. How would you describe what happens when I move from 0 to 2? So in your own words, describe what happened to the original graph when I now added 2 to it. Okay, so say I put it back at 0 again. Now let's say instead of adding 2, pardon me, just get it back to 0, I'm going to subtract 2. What do you think will happen to that graph? All right, the correct answer is when I subtract 2, it's right there, the graph actually went down. Okay, so that's kind of exciting because we can move the graph around a little bit. Mathematicians use moving graphs around to try to fit data better. All right, so that's the k. So I just added 1, added 2, subtracted 2, and we saw that moved this graph up and down. Now we're going to look at a second version of this graph, and this time we're going to look at the h. So it's still the orange graph, and there still is a secret, or sorry, I should say it's still the red graph, and the red you can't see because the orange is on top of it. This time we're going to subtract h. So if you imagine, in a moment I'm going to move it. Remember that when we added k, when we added 2, we added 3, it moved up. We subtracted 2 or 3, it moved down. So this time, if you notice in the equation, this is not an accident. It says minus h. So I'm about to move this so that instead of it being minus 0, it's going to be minus 1. What do you think will happen? Make a guess. What will happen to the graph if I change that to x minus 1? All right, let's see what happens. So I am doing x minus 1, and I'm guessing that did not go the way you expected it. What if instead of minus 1, it was minus 3? Here's what it would look like. So how would you word that? If I were to go f of x minus 3, what direction did the red graph move? Hopefully you said it moved to the right. All right, I'm going to reset it back at 0, or do my best to. And then now I'm going to move the graph to the left. How do I do that? Instead of subtracting 2 or subtracting 3, I'm actually going to subtract a negative, or subtract a -1, or subtract a -2. In this case, I'm actually going to subtract a -4. What happens when we subtract a negative? That's right, it's really adding. So really, it's going to be like we're subtracting, and I said I'd go 4, just to really push the envelope here. And that's what it did. So it was at the red spot, and now it's moved. So if I subtract a -4, it actually makes it go to the left. So keep in mind, big picture, if I do things to the outside in the K spot, that's moving it up and down. And if I do stuff to the H spot, that's moving it sideways.